ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾವು ಈ ವಿಡಿಯೋದಲ್ಲಿ ಹಾಫ್ ರೇಂಜ್ ಕೊಸೈನ್ ಸೀರೀಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಕೆ ಹೋಗ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸಲ್ಲಿ ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಅಂತಂದ್ರೇನು, ಒಂದು ಫಂಕ್ಷನ್ ಕೊಟ್ಟರೆ ಓವರ್ ದ ಇಂಟರ್ವಲ್ ಐದರ್ 0,2π ಆರ್ 0,2l ಆರ್ ಎನಿ ಇಂಟರ್ವಲ್ ಆಫ್ ಲೆಂತ್ ಯೂಶುವಲಿ 2l ಆರ್ 2π ಹೌ ಟು ಫೈಂಡ್ ಇಟ್ಸ್ ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಇದೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಅದೇ ರೀತಿ ಈವನ್ ಮತ್ತು ಆಡ್ ಫಂಕ್ಷನ್ಸ್ ಅಂತಂದ್ರೇನು, ಈವನ್ ಮತ್ತು ಆಡ್ ಫಂಕ್ಷನ್ಸ್ ಕೊಟ್ಟಾಗ ಅದರದ್ದು ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಕಂಡುಹಿಡಿಯೋದು ಹೇಗೆ, ಇದ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಹಾಫ್ ರೇಂಜ್ ಕೊಸೈನ್ ಸೀರೀಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಹಾಫ್ ರೇಂಜ್ ಕೊಸೈನ್ ಸೀರೀಸ್ ಅಂತಂದರೆ ಯೂಶುವಲಿ ಹಾಫ್ ರೇಂಜ್ ಸೀರೀಸ್ ಅಂದರೆ ಏನಂತ ಫಸ್ಟ್ ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ಮುಂಚೆ ನಾವು ಯಾವುದು ಫಂಕ್ಷನ್ಸ್ ಎಲ್ಲ ತಗೋತಾ ಇದ್ವಿ, ದಟ್ ವಿ ಯೂಸ್ ಟು ಟೇಕ್ ಆನ್ ಇಂಟರ್ವಲ್ ಆಫ್ ಲೆಂತ್ 2l ಆರ್ 2π. ಬಟ್ ಇಯರ್ ಫಂಕ್ಷನ್ ವಿಲ್ ಬಿ ಗಿವನ್ ಆನ್ an interval of length pi or l. ಸೊ ಮುಂಚೆ 2π ಅಥವಾ 2l ಇರ್ತಿದ್ದ ಇಂಟರ್ವಲ್, ಇಲ್ಲಿ ಪೈ ಅಥವಾ ಎಲ್ ಅಷ್ಟೇ ಲೆಂತ್ ಇರುತ್ತೆ. ಸೊ ಮುಂಚೆ ಇದ್ದ ಇಂಟರ್ವಲ್ಗಿಂತ ಆಫ್ ದ ಲೆಂತ್ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಎರಡು ಥರದ ಸೀರೀಸ್ ಬರುತ್ತೆ, ಹಾಫ್ ರೇಂಜ್ ಕೊಸೈನ್ ಸೀರೀಸ್ ಮತ್ತು ಹಾಫ್ ರೇಂಜ್ ಸೈನ್ ಸೀರೀಸ್ ಅಂತ. ಸೊ ಇಂಟರ್ವಲ್ ಮತ್ತು ಫಂಕ್ಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಅದರದ್ದು ಹಾಫ್ ರೇಂಜ್ ಕೊಸೈನ್ ಸೀರೀಸ್ ಕಂಡುಹಿಡಿಯಬೇಕು ಅಂತಂದರೆ ರಿಮೈನಿಂಗ್ ಆಫ್ ದ ಇಂಟರ್ವಲ್ ಫಂಕ್ಷನ್ ಈವನ್ ಆಗೋ ರೀತಿ ನಾವು ಅದನ್ನು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಬೇಕು. ಡೆಫಿನೇಷನ್ ಆಫ್ ದಿ ಫಂಕ್ಷನ್ ಶುಡ್ ಬಿ ಎಕ್ಸ್ಟೆಂಡೆಡ್ ಸೊ that should be even on 0,2π or minus pi, pi. ಅದೇ ರೀತಿ if you want to find the sine series of sine series of the function, then you have to extend the definition of the given function in the remaining half of the interval such that the function should be odd. That is the idea behind half range series and half range series. Now here to make it simpler, to find the half range cosine series of the function, don't worry about extending the definition of the function. Just treat the given function as an even function, then use the formula and definitions. So how to find a0 and a this formula and this the Fourier series expansion of the function over of an even function over 0,π, that you have to use. So clearly now make it clear. I have a function f of x given on interval 0,π. Now I need to find half range cosine series of the function of the given function. Now I will treat this function as even. So when the function is even over the interval 0,2π or minus pi, pi, the series expansion will be given by f of x equal to a0 by 2 plus summation an cosine x, where a0 equal to 2 by pi integral 0 to pi f of x dx, an equal to 2 by pi integral 0 to pi f of x cosine x dx. Whether the interval is 0,2π or minus pi, pi, this definition is same. Similarly, suppose you are given with a function over the interval 0,l and you are asked to find the cosine series, half range cosine series of the function. Then treat f of x as even function and use this one, f of x equal to a0 by 2 plus summation an cos of n pi x by l. As usual, a0 equal to 2 by l into integral 0 to l f of x dx, an equal to 2 by l into integral 0 to l f of x sin n x, cos of n pi x by l into dx. So only thing is, half range cosine series means the function is even. Keep that in mind. Half range sine series means the function is odd. Then use respective formula to determine constants and hence the Fourier series expansion. Now I have considered first problem. Here I will consider two problems. One is on 0,π, another one is on 0,l. So given the function f of x equal to x sin x over 0,π, you have to find its Fourier cosine series or half range cosine series of f of x, and then you have to determine, deduce this expression pi minus 2 by 4 equal to 1 by 1 into 3 minus 1 by 3 into 5 and so on. So first, as usual, the solution of this problem involves two steps. First step, you have to find the cosine series of f of x. Second step, you have to find deduce the expression. So let us start with the Fourier series expansion. Solution. Given f of x equal to x sin x, the Fourier cosine series is given by So I have this one. Call this as equation 1. F of x equal to a0 by 2 plus summation an cos nx n ranging from 1 to infinity. I will call this as equation 1. Now I need to determine a0 and an. Then substitute in equation 1. So to find number 1 a0, we have a0 equal to, use the formula 2 by pi integral 0 to pi f of x dx. So right from here, so a0 equal to 2 by pi integral 0 to pi x sin x dx. I have just substituted for f of x. Now here I have product of two functions under integral sign. You have to apply integration by parts or Bernoulli's rule of integration. So I'll write here 2 by pi, applying Bernoulli's rule of integration. First function is x, second function is sin x. So first function x into integral of sin x, that is minus cos x by minus cos x by 1, or simply minus cos x, minus derivative of x 1 into integral of minus cos x, that is minus sin x between 0 and pi. So this term vanishes because sin 0 is also 0, sin pi is also 0. So here minus 2 by pi, a0 equal to minus 2 by pi, this negative sign I have taken outside, into x cos x between 0 and pi. Now substituting on the limits, we will get minus 2 by pi, upper limit pi into cos pi is minus 1, so pi into minus 1, or simply minus pi minus 0 into cos 0, that is 0. So minus pi did cancel, you get only 2 there. And therefore a0 by 2 equal to 1. Keep this in mind. a0 by 2 is 1. So next I have to determine a. So first I have determined a0. So a0 by 2 I want. So a0 by 2 I have written there. Next to find an. An equal to, write on the formula to determine an. An equal to by pi integral 0 to pi f of x cosine x dx. Substituting for an, I'll write from here, an equal to 2 by pi, substituting for f of x integral 0 to pi x sin x into cos nx dx. So here this is of the form sin A cos B. So I will do one thing, I will write this as integral 0 to pi 2 by pi integral 0 to pi x cos nx sin x dx. And we know that cos A sin B equal to 1 by 2 times sin of A plus B minus sin of A minus B. 1 by 2 times sin of A plus B minus sin of A minus B. Here A is nx and B is x. So using that formula here, so I will get an equal to 2 by pi integral 0 to pi x times sin of A plus B, that is sin of nx plus x, that I can write as sin of n plus 1 times x, minus sin of A minus B, sin of n minus 1 into x divided by 2 dx. So these two cancels with this. Now I can apply, treating x as the first function and this as the second function, apply integration by parts. I will get an equal to 1 by pi first function, that is x, into integral of second function. Integral of sin of n plus 1 x is minus cos of n plus 1 x divided by n plus 1. Integral of sin of n plus 1x is minus cos of n plus 1x divided by n plus 1 minus integral of sin of n minus 1x is again minus cos of n minus 1x divided by n minus 1 minus derivative of x 1 into integral of minus cos of n plus 1x by n plus 1, that will be minus sin of n plus 1x by n plus 1 whole square minus integral of minus cos of n minus 1x by n minus 1, that is minus sin of n minus 1x divided by n minus 1 whole square. This between the limits 0 and pi. So if you apply upper limit, you get 0. Even if you apply lower limit, you get 0 again. So this term vanishes. That term vanishes. So remain with an equal to 1 by pi. So pi into minus cos of n plus 1x. We know that cos of n pi is minus 1 power n. So it will be minus of minus 1 power n plus 1 divided by n plus 1 minus again minus of minus 1 power n minus 1 divided by n minus 1. Applying lower limit, you get 0. So this will be, I can write as 1 by pi. Yes, this pi cancel with this. Okay. This will be minus of minus 1 power n plus 1, it will be minus 1 power n. Similarly, minus of minus 1 power n minus 1, that is also minus 1 power n. So it will be minus 1 power n divided by n plus 1 minus again minus 1 power n divided by n minus 1. You can take minus 1 power n outside, then take the LCM of this. That will be minus 1 power n times 1 by n plus 1 minus 1 by n minus 1. So simplifying that expression, you get equal to minus 1 power n times n minus 1 minus n plus 1, n minus 1 minus n minus 1, it is minus 1 divided by n square minus 1. So minus n plus n get cancelled, we will get minus 2 times minus 1 power n divided by n square minus 1. So that is an. And now an is valid only when this denominator is not 0. So I must have n not equal to 1. If n equal to 1, this is not valid. But I need to find a0, a1, a2 and so on an up to infinity. But now I have not yet determined this one. So to find a1, I have the formula for an. There I take n equal to 1. So I get a1 equal to 2 by pi integral 0 to pi x into sin x into cos x dx. I have taken n equal to 1 in an. Now 2 sin x cos x can be written as sin 2x. 2 sin x cos x can be written as sin 2x. So it will be a1 equal to 1 by pi integral 0 to pi x into sin 2x dx. Apply integration by parts. What you will get? First function is x, so 1 by pi x into integral of sin 2x minus cos 2x by 2 minus derivative of x 1 integral of minus cos 2x by 2 minus sin 2x by 4 between 0 and pi. As usual, this term vanishes, and here minus 1 by 2 can take outside. a1 equal to minus 1 by 2 pi times, applying upper limit, you will get pi into cos 2 pi is 1, pi into 1 minus lower limit 0 into 1, you get 0. So this pi cancels with this, it is a1, therefore a1 is minus 1 by 2. Now substituting these values in equation 1, substituting in 1, we'll get f of x equal to, that is x sin x equal to a naught by 2 1 plus a1 cos x, that is minus 1 by 2 cos x, plus summation n range from 2 to infinity minus 2 times of minus 1 power n divided by n square minus 1 into what is correct is cosine x. So this is the required off range cosine series of the function f of x equal to x cosine x, x sin x. Now I need to determine, I need to deduce an expression from this one, that is pi minus 2 by 4 equal to 1 by 3 into 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 and so on. So I'll put x equal to pi by 2. Put x equal to pi by 2. Why I should x equal to pi by 2? If you look into the given series, they have product of odd terms in the denominator. Here denominator is 1 by n square minus 1. That I can written as 1 by n plus 1 into n minus 1. I should get odd numbers here. That means n must be even. So when n is even, you should have this term, some value in this term. When n is odd, the value should vanish. So I'll recall this one. Cos of n pi by 2 is 0 if n odd, and it will be minus 1 power n by 2 if n even. So if you recall this result, you will get, I will get why I have taken x equal to pi by 2. Now putting x equal to pi by 2 here, you will get x into sin x, that is pi by 2 into sin pi by 2. Sin pi by 2 is 1 equal to 1 minus cos pi by 2 0 minus 2 into summation n ranging from 2 to infinity n odd, n even minus 1 power n divided by n minus 1 into n plus 1 into minus 1 power n by 2. Minus 1 power n into minus 1 power n by 2. The product of that 2 will be minus 1 power n by 2 again. So pi by 2 minus 1 equal to minus 2 times of summation n ranging from 2 to infinity n even minus 1 power n by 2 divided by n minus 1 into n plus 1. Now expand right hand side term, you get pi minus 2 by 2 equal to minus 2 into, expand in this, n equal to 2, so you get minus 1 by 2 minus 1, 1 into 3, plus next n equal to 4, you will get plus sign, 1 by 4 minus 1, 3 into 5 minus 1 by 5 into 7 and so on. Now multiplying this negative side inside and taking this 2 to the left hand side, pi minus 2 by 4 will be 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 minus and so on. This is the required series. So in this way we can find the Fourier cosine off range series or off range cosine series of the given function. Only thing is, when you need to find the cosine off range series, you have to keep or you have to think that function f of x as an even function. Then in case of cosine series, you have to treat the given function as odd function. The rest of the thing is same as even and odd functions, so that you can proceed easily. Thank you.